Hello, my name is David John. I'm the inventor and builder of the TheJohnDevice, as I call it here. And this is what people generally will refer to as a gravity engine. That's not exactly correct, but it's a good term because it's something people are familiar with. What we've got is a system here that we're going to have weights on, and the weight is going to be rotating around this central shaft. And that shaft, in this case, is just on a base. Ordinarily that would be on an electrical generator if you wanted to produce electricity. It actually just makes torque, so torque can be used to drive pulleys, propellers. There's all kinds of rotary devices that this can drive, and that's something that, again, people want to rush to. You can make electricity. Yes, you can, and that's what is very exciting. I understand. That's just one of the things that this can do in that respect. So what we've got, this central shaft. The first thing you have to understand we're going to be discussing with science is just a couple of terms. The first term is the word torque. Many people are familiar, if they've done car work, let's say, that you have to fasten a certain amount of foot-pounds of torque on a bolt when you tighten the bolt. And you have a torque wrench or some device to show you what that is. Torque, let's just take this pole here. You can just envision, if I have a weight, this is a 2.5 pound plate, if I have a weight, say on this pole, and I'm holding it very close to myself, kind of think of that, me as the torque shaft. By having the weight close to me, it's easier to hold it, it's easier to move it like this. As we all know, if you move that weight out, in this case, it gets much harder to hold the weight up. That is torque. You see right there with my own hand, it's much easier to hold it. As we slide it out, it gets progressively harder. Everybody knows this, everybody's experienced it in their life. So that is what's called torque. We use the term a lot in this world of Newton meters and newtons. In America, this is a 2.5 pound plate. To convert anything into newtons, you multiply by 4.45 or thereabouts. So we then calculate what the newton weight of a certain mass is, and we then can take, in this case, the distance from the central shaft, let's say me, and you use a multiplier to alter that. So the closer you get, the easier, the lower the torque rating is. If it's farther out, it's a much heavier, higher torque rating. Torque is actually not just calculated on the distance. That's just called the Newton meter. Torque is then how fast, taking that weight at a certain distance, it's how fast we can spin it or turn it. You think back to that wrench analogy. In the world of a bolt or a wrench, your RPM or your speed is essentially considered nothing because you're moving it so slowly as you get to that final tightening point. But in the world of power and energy, speed is practically everything when it's combined with mass. So we want the amount of force to rotate that amount of Newton meters, the farther the distance, and then we calculate the RPM, how much it takes to go around at that distance. So in this case, that's called torque. I'm sorry, before we get to this case. And then how you calculate watts. First of all, watts, we all think of watts as electricity, and watts is electricity in that respect. But watts is a very transportable scientific term. Many people, maybe watching this video, don't really know that. They think of volts and watts and amps and all those thingamajigs of electricity. That's true, but watts are a word, is a concept watts transports across many fields. For instance, 1 horsepower. Your car has so many horsepower. Each horsepower is roughly 746 watts. That's why in the car world, when somebody says, oh, my car stereo actually is a 1200 watt stereo or whatever, you can actually say, oh, well, that deducts this many horsepower from your engine if you have it at full volume. So watts is something we use. Voltage, for example, you guys are familiar with a taser that hits you with 50,000 volts of power, but you're okay to some extent. I don't know, I've never been tased. But then you take the people that touch a wall outlet that's only 110 volts, 120 volts, and they get killed. Well, of course, that's because a wall outlet has a lot of amperage behind it. So it's a huge amount of power sitting there. Whereas a taser has an enormous voltage, 50,000, 100,000, whatever number they make up for good marketing. But the amperage is, 0.00000. It's such a small number that you almost can't see it. In either case, you can just multiply that out and you get watts. And that's what really happened. So the taser that hit you with 50,000 volts of juice to socket, you may have only gotten 5 watts of power, but it sounded impressive. That's why scientists use watts. You can't impress watts. Watts are the kind of final equator there. So back to torque. First of all, you can Google it. I'm also going to be putting up the JPEG. But it's very straightforward math, folks. I saw it on a TV show about elementary kids. So a mass at a distance moving at a certain speed, we then can calculate torque. That torque can be translated, this is science, folks, into watts, a very standard unit of science. So with that said, let's get down to business here. We've got, in this case, a 4.4 pound weight. It comes out to 19.58 newtons. The math's going to be on the stuff. I'm not going to go into all that right now for this video. The way the TheJohnDevice works, we're going to be rotating that mass on this shaft you see by using this mechanism at the top, which is nothing more than a mechanism. It's just a gear I made by hand with a connection through it, so it allows it to rotate. On this is a motor. This motor, by the way, as we do math today, this is only its maximum rating. It's a 12 volt motor rated at 0.35 amps maximum, which, if you do the math, means that its max is 4.2 watts. That's the most watts this motor can ever put out. So to highlight that we're not going to be pushing the bubble there, I'm going to be running the system today off of a 9-volt battery. And let's get it started. I do want to show you too, this is the meter. I'm going to be grabbing the camera to show you the actual numbers at some points. This is a Doc Watson, it's called. It's a commercially available, Google it, whatever, I just bought it on the internet. It's used by RV people and car people and electronics people. Everybody uses them. That's a very well-known standard brand. Actually, I'm going to be using so little wattage today that this has trouble displaying the watts, if you see what I'm saying. It's so low that it almost doesn't have enough to tell it what to put on the screen. So it has an option to plug in its own little battery to light the screen up, which I will do now. And so that's what you call light it up. It just booted and now it shows the watts. It's a neat product because it shows you your watts, your amps, and your volts. So there's no kid, you don't have to guess. And then it also shows you accumulative amp hours, watt hours, and all that. It's a great little product. That is being controlled by some little controller I bought on the internet. Notice the dock is uphill from it. And again, I can unplug this battery. That's a non-issue, but I just leave it for right now for benefit. This is what will control the speed of the motor, and here we're going to be plugging in the 9 volts. So hey, while we're doing that, let's just go ahead and get that plugged in, and we'll turn it on. Now, this can start it, as you can see. I give it a little help because this isn't designed as a starter motor, but it can function that way. It's really designed once we get her going. So I'll turn up my speed control. That's again the knob right here. And that's a critical factor when you talk about the concept of a gravity engine, is speed control. I hope you're listening, because people always envision in their mind, well, you know, a gravity type of engine is going to be okay, but it's going to slow down. You know, everyone has that feeling. Well, what about later, in a few hours? It's going to... You see, that's kind of a difficult concept, because my drive motor is actually driving this around. So it's not sort of... Gravity is my assistant in doing the work, but I'm the one that's steering it, if you will. Now, this isn't hooking up right, so I need to adjust the height on the top. But let me just do a 1 1000, 2 1000, 3. Yeah, see, we're not even up to 30 RPM. It keeps missing on the top, so. It's only hitting it every few times around. Quite there. Anyway, it doesn't, since it's actually skipping, it has no problem of running 30 RPM, and this motor will go to 60, by the way, is its maximum rating. And if it was biting on the teeth, I can just hook it up and make it go 60. Although I can't do that with only a 9 volt, how I mentioned. It needs 12 volts to go to 60 RPM. I need to fix that top.